Okay, thank you. Hello, everyone. Assalamu alaikum and good evening to our senseis and partners from Japanese side. I'm Muhammad Tawshif Islam, master student in Jahangir University and also a member of Working Group 4. Well, I'll be presenting the section 5.2, which is a part of the chapter 5, that is the emergency evacuation and response for Dhaka city, and my research title was Road Network Vulnerability Assessment for Seismic Hazard in Urban Area. Well, already you have seen the title, and it is mostly focused on the network routes of an urban area, and everyone knows that the transportation routes or the network routes are very crucial to a urban area for its proper functioning, because any disruption in the transportation network can completely damage the connectivity within the urban area, which eventually leads to a higher risk towards evacuation operations. Now, to conduct my whole study, we have evaluated two objectives. For the first one, we have explored the building damage vulnerability scenario in terms of seismic threat, and the second one explores the road network vulnerability for earthquake within the study area. In this regard, we have incorporated three distinct methods and combined them into an integrated scenario, where the first method is utilized in VR, which is also known as visual reading. The second method is damage probability matrix, and finally the road closure probability. And if I can show you the flowchart of our whole study in a more generous way, you can see that the orange portion shows that it is mostly focused on the building assessment, and the green portion focuses on road blockage assessment. And if we can compile the previous methods into this flowchart, we can see that the VR actually identifies the building vulnerabilities, and the damage probability assesses the building damages. And finally, the road closure probability, which you can see in the right portion of the slide, sorry, that calculates the road blockage scenarios and debris. Now, as you know that there are several ways to evaluate a building vulnerability for seismic threat, for example, EMS 98, FEMA 154, and etc. However, we have selected the VR method in collaboration with Working Group 4, as they have performed several experiments in terms of Bangladeshi structures with this VR technique. So as per their suggestion, we have selected the VR technique in this regard. And if I can give you a short demonstration of the VR rating system, I can say that it is a cross-sectional, it focuses on the cross-sectional areas of columns and masonry infills for masonry RC buildings. And you can see the equation in this slide, and mostly it focuses on the number of stories, shear column strength, thickness of masonry infill, thickness of concrete wall, and so on, some other factors. And then we go to the damage probability matrix, and it is basically a statistical correlation between the macroseismic intensity and the apparent damage described in terms of damage rates. Basically, it focuses the buildings with the same type of behavior reacts similar way. And as we can categorize VR, the output of VR, we can categorize into certain grades. We can then finally merge them with the categories of damage probability matrix. You can see the color range grades from light color to deep one, and the deep color presents more vulnerability in terms of damages. And sorry, and finally, we have calculated the debris with FEMA 329 formula to justify how much debris might generate within this road section. And this figure shows that how the buildings can be collapsed during earthquake or seismic vulnerability. Now, for our study area, we have selected ward number 30, considering its multiple criteria and characteristics in terms of mixed use or open spaces, availability of mixed functionality, and so on. This is my study area. You can see that it is mostly located in the Shamoli section, which is known as other board, and these yellow marks and other categories are mostly like the building use types of uh, uh, within this area. And this portion shows that most likely the structures utilized in this area has been used for residential purposes. However, we can also see some other uses within this area, like mixed use or commercial and so on. Now, before selecting the primary road, I would like to share some key findings that why we have selected road number 7, because this is the most important road that connects the ring road from the right side to the left part of this study area. And hello, hello. Can you please mute? Hello.
Thank you for your
okay. Thank you. Thank you. Okay. In this regard, we have selected all the buildings within alongside this road number 7, and that incorporates about 42 buildings within this area. Now, after conducting our VR survey, we have identified that this scenario has been identified within this area, where the green color shows less probability of damages, and vice versa, the red color shows most highly damaged probability. And you can see that though there are less amount of buildings which are identified as highly vulnerable, that is 90 to 100% building damage probability, but most likely the buildings of medium range vulnerability has been identified within this area, and that is around 40%. But the impact shows some different result in terms of blockaging the whole road. And this is the final output of our study, where 3 portion of the area has been identified where the roads gets completely blocked during an earthquake event if the building collapses. And however, the other color shows the respective damage probability, respective road closure probability in terms of blockages. Now, if I can sum up the whole scenario in certain sentences, we can see that there lies significant amount of vulnerable buildings which can cause complete road blockage within this area. And you can see that even a single portion of road blockage can completely disrupt the whole accessibility throughout this road, because there lies very less amount of provision for alternative routes. And for the partial blockages, you can see that it can also affect the traffic flow by narrowing down the effective road width, because the total width of this road is around 20 to 30 meters. And if anything happens within that portion of area, it really disrupts the network. Now, for future challenges, we can see that VR method is quite reliable in terms of getting detailed structural vulnerability data, but it is quite tedious and time consuming, because you see that VR requires a thorough investigation of individual structures. However, the replication of such study in the urban area is surely difficult, but can also be very effective in terms of identifying vulnerable scenarios for emergency situation. Now, if I can wrap up the situation, I can say that this type of study is quite important and crucial for urban areas where congestion is very oftenly seen, because alternative route shows a significant importance in terms of emergency situation. And we considering the road network vulnerability impact while planning an urban area and transportation network guidelines, it would really help the overall view of our future planning situation to cope up with the future demand and mitigate the threats of earthquake vulnerability. That would be all from my side. Thank you, everyone. And I would also like to thank Associate Professor S.M. Naushad Hussain for guiding me and supervising me throughout the whole project. And I would also like to thank Professor Akhtar Mahmoud and Professor Michio Ubara for their generous support throughout the whole project. Thank you.